The theory of relativity is usually thought to be the most brilliant scientific theory of all time. But in my opinion, it's actually one of the most idiotic theories anyone ever came up with. Because one of the assumptions on which the theory is based is incompatible with the conclusions. Einstein published his theory of special relativity in his paper on the electrodynamics of moving bodies. And he starts out by stating that his theory is based on two fundamental assumptions, namely the principle of relativity and the constancy of the speed of light. Now, I don't think the speed of light is constant, but in this video I will focus on the other assumption, the principle of relativity. Now, the principle of relativity long predates Einstein, and it basically states that objects don't have an absolute speed, but only speeds relative to other objects. Now, this principle is easy to understand if you compare it with distance. Obviously, an object doesn't have a single absolute distance, but it has only distances relative to other objects. If you want to know the distance of a car, for example, there's no absolute answer. There are only answers relative to other objects. The distance of a car to Berlin, for example, is 100 kilometers, but the distance to another car only 100 meters. And the distance of the car to the sun is 150 million kilometers. And according to the principle of relativity, the same goes for speed. Now, normally speed is expressed relative to the Earth. So if the car is said to have a speed of 100 kilometers per hour, that is relative to a fixed point on Earth, like Berlin. But the same car only has a speed of 10 kilometers per hour relative to another car which is going 90 kilometers per hour relative to the Earth. And if you consider that the Earth orbits the Sun, that same car has a speed of 100,000 kilometers per hour relative to the Sun. And in the absence of other objects, it's impossible to determine what speed the car has or if it is even moving at all. Just like it is impossible to determine the distance of a car without reference to some other object. Now, something else in which speed is the same as distance is that it's symmetrical. So if the distance of the car to the sun is 150 million kilometers, then the distance of the sun to the car is also 150 million kilometers. And if the car is moving with 100,000 kilometers per hour relative to the sun, then the sun is also moving with a speed of 100,000 kilometers per hour relative to the car. Now, this might be confusing because people have been taught their entire lives that the Earth moves around the Sun instead of the Sun around the Earth. But according to the principle of relativity, it is just as valid to take the Earth as an unmoving reference point with the Sun and the planets moving around it. The only problem with taking the Earth as a non-moving reference point is that the planets then make very erratic and complicated movements, as you can see on the left. But if you take the Sun as a non-moving reference point, the planets and the Earth simply move in circles around it, as you can see on the right. So the heliocentric model with the Sun in the center is simpler to explain, but there's no evidence that the Earth is moving instead of the Sun. And according to the principle of relativity, it's even impossible for such evidence to exist because all movement is relative. So, to summarize the principle of relativity, objects don't have an absolute speed, but they have as many relative speeds as there are other objects. Any object can be taken as a non-moving reference point with a speed of 0, and no object has a higher or lower speed than any other object, except relative to a third object, like the Earth. So, two objects only have a speed relative to each other, and that speed is the same for both objects. So let's go back to Einstein's theory of relativity. One of his assumptions is the principle of relativity. So that means no object moves faster or slower than any other object. And he makes two conclusions. First, that objects with a higher speed experience slower time, so that means processes are slower for that object. And the second is that objects with a higher speed have a shorter length, so that's in the direction in which they are moving. But considering the principle of relativity, this is incomprehensible without asking the question, a higher speed relative to what? Einstein doesn't provide a reference point, and according to the principle of relativity, there is no objective reference point, so his conclusions are completely meaningless. Now, if I were to make a hypothetical theory that says the greater the distance, the slower the time, and the greater the distance, the shorter the length, it should be immediately obvious that this theory doesn't make any sense if I don't specify the distance relative to what. And according to the principle of relativity, the same goes for speed. So if you say the higher the speed, the slower the time, and the shorter the length, this is meaningless without specifying to what this speed is relative. Now, Einstein does not provide any method in his paper whereby you can determine which object has a higher speed. So it's impossible to make any practical predictions using the theory. And that's the origin of the twin paradox. This paradox is well known, but most people don't understand that it completely destroys the theory of relativity. So the paradox is the following. One twin leaves the Earth in a spaceship with an incredibly high speed and then returns, and the other twin stays on Earth. Now, Einstein predicts that the twin with the higher speed experiences slower time, so ages more slowly. So when they reunite, one twin is younger than the other. But which twin is younger? That's impossible to determine because the spaceship has a high speed relative to the Earth, but the Earth has exactly the same high speed relative to the spaceship. And this is not just a problem in this specific situation. This problem applies to all practical applications of the theory of relativity. So the theory is unable to make any practical predictions. Nevertheless, Einstein makes one prediction in his paper. Now, maybe because the problem would be too obvious if you consider linear motion, he makes it a bit more complicated by considering rotational motion. He states, "Thence we conclude that a balance clock at the equator must go more slowly, by a very small amount, than a precisely similar clock situated at one of the poles, under otherwise identical conditions." So the idea here is that the Earth rotates around the poles, so a clock on the equator rotates with a high speed around a clock on the North Pole, for example. And because it has a higher speed, the clock on the equator is slower than the clock on the North Pole. But the clock on the equator has a higher speed than the clock on the North Pole relative to what? Relative to the North Pole. And when you put it like that, it sounds retarded, but that is what Einstein is actually saying. Now, it might be intuitive to consider the North Pole as a reference point with a speed of 0, but according to the principle of relativity, there's no real justification for this. And you can just as easily use the clock on the equator as a reference point with a speed of 0. So on the left, you see the rotation of the Earth when you use the North Pole as a non-moving reference point, but in the middle, you see the rotation of the Earth when the clock on the equator is used as a reference point. And then the clock on the North Pole has a higher speed and should be slower. And then finally on the right, you see a third reference frame in which the Earth isn't rotating at all. And both the clock on the North Pole and the clock on the equator have a speed of 0, and they should go at exactly the same rate. Only in that case, the sun and the stars are moving with an incredible speed around the Earth. And a clock on the sun, for example, should be slower than a clock on Earth. Now, Einstein doesn't even consider these possibilities because he doesn't seem to understand the principle of relativity at all, and he just picks the North Pole as a reference point without justification. And by the way, this prediction of Einstein was also empirically tested, as can be read in the paper Relativity and Clocks, and it was found to be false. As you can read, a clock was transported from Washington, D.C. to Thule Air Force Base in Greenland, and another clock stayed in Washington, D.C. Now, Greenland is closer to the North Pole, so according to Einstein, the clock in Washington, D.C. should have a higher speed and therefore go at a slower rate. But this wasn't the case. The paper states there's no evidence for any anomalous latitude effect. The Einstein error of 1905 would have predicted a time difference of an additional 56 nanoseconds per day, or a total of 224 nanoseconds for the 4-day dwell time when the clock was in Greenland. So empirical evidence shows that clocks simply go at the same rate regardless of latitude, and that Einstein is wrong. So to summarize, one of the assumptions of the theory of relativity is inconsistent with the conclusions. It's impossible to make any practical predictions using the theory, and Einstein nevertheless makes one prediction, and that is found to be incorrect.